Hey folks, welcome to Get Git, Introduction to Version Control with Git and GitHub. I'm Evan Williamson, Digital Infrastructure Librarian at University of Idaho Library. So this is a workshop I really like to teach. Get Git is aiming to give you a really pragmatic, hands-on introduction to Git, covering all the basics that you're going to need to know to use version control on your own projects and kind of in your daily life. There's a lot of really fancy, complex things that Git can do, but the basics are really all you need to know for about 99.9% of collaborating and daily use, unless you're on some kind of giant worldwide software development project. So this is really Git for academics, for librarians, for engineers, biologists, English majors, just Git for anyone who wants to learn those basics, use version control to make their lives better and make their projects better. So to provide this really kind of solid understanding of these basics, we're going to introduce kind of the concepts today, but then we're going to jump in on the command line to see the Git commands and how that workflow works right there on the command line. Once you start regularly using Git with your repositories, you might actually use some GUI helpers that can make it a little bit easier, that are integrated into your text editor or some standalone apps such as GitHub Desktop. But today, we're going to focus in on the command line because that really helps you understand the fundamentals of how these commands work, what they're doing, and clarify how these tools work together, and how the file system works underneath. So, learning on the command line is going to sound a little bit intimidating, perhaps, but it's going to pay off in the end, and you don't have to do it full time after this workshop. So, let's get started. The website is at this address here, evanwill.github.io/get-b, and I'll put the link down in the description of the video if you don't have it. The website is up here is just going to be a real clear outline to what we're going to cover, and we're going to have a series of videos for essentially each section of this website outline, so it'll be broken up into a few chunks. So why do we want to learn about version control at all? Do you have files like final.txt, final-revised.txt, final-revised2.txt, final-revised2-revised.txt? And so there's this great comic, or a couple of great comics here from George Cham, with using these file names to embed all the information, all these revisions that we've done to these files over time. And it's a really common practice. It's something that we all do. We have these folders, and we have folders inside of folders, and the file names with all kinds of numbers and qualifiers added onto it. So it's a sort of local version control system which completely depends on your memory and your personal organization to avoid errors and utter confusion. Luckily, we do have software that can handle some of this for us, from the basic track changes. Now Google Drive has some pretty good version control kind of built into it, where you can look back at what people have done in their editing over time. And there's also big centralized systems such as SVN that software companies have been using for years to do track changes on their projects and collaborate. So a version control system is a piece of software that's going to record the history of what was changed in a folder of files, who made those changes, and why they made them, so that it will really facilitate the development of this project and the collaboration on those files. And version control system allows you to explore that history so that you can better understand the project's development, all the choices that were made along the way, which is going to enable you to debug issues or undo errors and just kind of understand how the work is going. So if you get into it, version control really will make your life better. It's better than trying to have all those different file names and different copies of the files that you can't sort out. How I really actually got started in it using Git was that I would keep all my notes in plain text files in a folder that was called Notes, and I had them on a USB stick, and I have a work computer, a work desktop, I have a work laptop, and I have a personal laptop, and I would move it on this USB stick around on all these different computers. And of course, you end up with them completely out of sync, and there's no way to figure out how to put those notes all back together, which ones were more up to date, and some of them had multiple changes that overlapped, and I didn't want to lose it all. And so in the end, I popped all of those notes into a Git repository, and I was able to dump the other ones in and Git would help me sort out the mess, and I was able to make some order to that chaos and find all the notes that were actually up to date and merge it all together. So that's really where I actually got started. And the piece of version control software that I used is Git. And this is a free distributed version control system that was originally developed for a huge software development project, the Linux kernel. However, it's been adopted by, it's the most popular by far version control system right now. It's adopted by all kinds of people for all kinds of contexts. It's really fast, flexible, and it can be used on any scale. You don't need a big centralized server or anything. That's what's great about being a distributed version control system. And so people are using it for their personal notes, like me, your research lab code, enterprise software code, or something as large as your detailed plans for intergalactic empire. So using Git is going to give you a lot of benefits beyond track changes. So if many of you are familiar, in working in a Microsoft Word document where we do have this thing called track changes. You suggest some changes, it tracks all of the information there. And then you go into that document and you start accepting those changes or rejecting them. But when you do that, all of that history, the change happens and then the history's lost. So it isn't really a version control system where it is not storing the changes over time, and it doesn't have a history that you can explore afterwards once you've accepted all those changes. That history disappears. So in using Git, we're going to have something a little bit different. We're going to actually have a history that is permanent and linear, and really records a lot of information about who's making the changes and why they were doing it. So to get started, our project is going to be stored in a folder of files, and it's really just a normal folder of files on your computer, just like any other folder of files. But that folder we're going to call a repository, or a repo for short. And inside of that folder of files is actually going to be a little hidden folder called .git, and that's where the actual history that's stored and tracked by Git is going to be kept. And so that's part of why Git is a distributed version control system, because this repository, the full history of it, no matter how many people are collaborating on it, is actually going to be stored in this little folder inside of your repository, whether that repository is on GitHub or on your local machine. You don't need a centralized server to be using Git. This is really great for collaboration, for fast performance, for the sustainability of having a copy offline in your own on your own hardware, and not needing to ask a server every time that you want to explore the history or understand what's happening. So rather than storing this series of copies of files with different file names and revision numbers, like we were doing up here, where we had, this folder gets bigger and bigger as we add more and more revisions in it. Instead of doing that, Git is essentially going to capture a snapshot of your project, the kind of state of your project, each time you tell it to commit. And so we're going to be doing that in a little bit here, but commit is an important concept. And so each commit is going to record who's creating that commit, their email, the time it was done, the exact changes that are made. So how is it different from the last commit? And then it's going to store all of that information away permanently in that little history that we have here hidden in our folder. And so here's maybe the first version of our document. When we're looking at our folder of files, it's always just going to be one document. We're not going to have multiple copies of it. We're not going to change, I'm not going to add numbers to that file name or something. It's just always going to look like a regular file in a regular folder on your computer. But you're going to have your document. You're going to do some edits right here. You're going to add some more edits right here. And so we have different versions, and those versions are essentially captured inside that history so that it can be reconstructed at any time. So you really kind of start thinking about your changes. So this little bit of change is one of the things that's going to be recorded in a commit. You can start thinking of those changes as separate from the document itself. And so from Git's point of view, that current folder that you see in your folder that looks like a regular folder in your files is really just a version that's made out of a specific set of those changes. So we can easily pull out this version, or this version from Git, and it can reconstruct all those different versions by jumping through those commits. and yet you'll never lose any of that history of all of those changes over time. It's all safely stored away in that Git .git directory, that history that comes with that repository. So this allows Git also to really efficiently branch, compare, and merge different sets of changes together, so that people can work in parallel, or you can work in parallel with yourself on different computers, for example, and then sync all those files back together. So we start out with a document here. Maybe I make a branch and I add some changes here, and somebody else, my collaborator, also makes a branch and adds some different changes here. So now we have these two different versions that are derivative from this first document. So Git is also able to merge those all back together and in a more or less automatically. And so we can take this version and this version and figure out what the final version of those two put together should be. And when you're making these commits, making these changes, Git is only going to add data to that history. It's never going to delete any information. So this is going to make almost everything undoable. And the whole point of that, and kind of why this is such a cool thing, is that you can make changes, you can experiment without fear of messing up your original versions, and without losing any documents. So you're supposed to be fearless when you're using Git version control. As long as you've made that commit, captured it in the history, then it's always going to be there, and you should feel brave to experiment, try out new things when you have to debug issues in your code or your notes. Last thing I want to mention in this section is plain text workflow. So Git is really designed for tracking plain text files. So all your code, let's say your Python and your R, or your HTML, or Markdown, is plain text. It's really just files that contain text characters. Even if there's all kinds of different kinds of code or markup, XML in there, the format of the file itself is just plain text. Now, most of your image files, video files, or proprietary document formats such as Microsoft Word's docx are not plain text files. Some of your data formats, CSV, TSV, JSON, YAML, XML, are plain text, but most of your proprietary spreadsheets and database files are not going to be plain text, so Excel files, Access databases, etc. So those things that are plain text, Git can tell you exactly what is going to change. It's really looking at it line by line, but it can't understand what's going on inside a binary file, such as an image or a video or a proprietary document format. So it's going to know that those binary files have changed, but it can't really tell the exact differences of what has changed inside of it. So Git is really not designed for managing your Word docs, your PDFs, your images that are going to change a lot over time. And having a bunch of those binary files in a Git repository is going to lead to really bloated repository sizes that saves these different versions in the history. So generally, you're going to want to actively edit and track those types of files somewhere else, maybe in OneDrive or in Google Drive or something like that. If you're creating documentation or you're writing content, consider using a plain text writing workflow like Markdown or LaTeX instead of Microsoft Word. It's going to really actually make your life a little bit easier, and it'll work inside of a Git repository, so you can really have the power of this version control at your fingertips to collaborate with. So that's just something to keep in mind when you're setting up your repository, when you're thinking about what's going into this repository and what you're going to track using it. And so that's the end of this first introduction section. Tune in for the next video where we'll walk through how to get started on GitHub and what your repository is going to look like on that platform. Thank you much.